Hello, and welcome to another lesson from Level Up Mathematics. Today we will be exploring the angle pairs formed when two parallel lines are cut by a transversal. Before we do, let's look at an example. In the diagram below, lines A and B are parallel, and line T is a transversal, or a line that intersects them. When two parallel lines are cut by a transversal, 8 angles will be formed. Now, I like to use something called the X and O method to identify these angles. So what I do is I identify all of the acute angles and I label them with X's. So here's an acute, an acute angle. Now, all of these acute angles that I just labeled are going to be congruent to each other. So every X is congruent to every X. Then I labeled the obtuse angles with an O. So every obtuse angle, I'm going to label it with an O. And the relationship between the O's is that every angle labeled with an O is congruent to every O. Okay. Now, we also have another relationship in that every X plus an O is going to equal 180. So if you have an angle X plus an angle O, their sum will be 180 degrees. So the 8 angles formed by the transversal will either be congruent or supplementary. They'll either be congruent or supplementary. Now, before we get into actually finding the measures of the angles, we want to review some vocabulary that you have learned in previous courses. So let's start here with a linear pair. A linear pair are angles formed when two lines intersect each other at a single point. So an example of a linear pair might be angle 5 and angle 7, angle 5 and angle 7. Or you might have angle 3 and angle 4. Another example of a linear pair might be 6 and 8. Or you might have 1 and 2, all right? All of these angles are linear pairs. So let's write down some examples over here. We said angle 5 and angle 7, angle 6, and angle 8, angle 3, and angle 4, angle 1, and angle 2. Now, there are more linear pairs. I'm just listing a few of them. But the relationship between all linear pairs is that they are supplementary to each other. Supplementary. Which means, if you remember, they add to 180 degrees. All right? Now, corresponding angles. Let's look at corresponding angles now. Corresponding angles are angles which lie on the same side of the transversal, on the same side as lines A and B. Another way to think of corresponding angles is they are the matching, whoops, I can't spell matching, it seems. They are the matching corners. That's another way to think of the corresponding angles. Now, when I was your age, I used to remember that by the CO for corners and the CO for corresponding. So that's just the way I helped keep corresponding angles straight in my brain. If that doesn't help you, just ignore it. But it seemed to always help me remember what a corresponding angle is. So an example of a corresponding angle, so let's say I had angle 7. Look at the diagram and see if you can figure out which angle would be the matching corner. Well, hopefully you said angle 3. Those are called corresponding angles, all right? Let me grab another set of corresponding angles. What if I had angle 8? What do you think the corresponding corner would be, or the matching corner? Hopefully you said angle 4. All right, let's see. How about angle 5? Well, that would correspond to angle 1, angle 6, angle 2. All right, so let me write those down. Let's see, we had angle 7 and angle 3, angle 5, and angle 1, angle 8, and angle 4, angle 6, and angle 2. Now, the relationship between corresponding angles is that they're always congruent to each other. They'll have the same measure. So if you know angle 7, you would also know angle 3. All right. Now, vertical angles are pairs of opposite angles formed by intersecting lines. Now, we used vertical angles a minute ago when we were labeling our X's and O's. So, for example, angle 7 and angle 6. They're opposite angles formed by intersecting lines, and they're congruent to each other. We could also have 5 and 8. 5 and 8 are vertical angles. All right, so let's write those down. Angle 7 and angle 6, angle 5 and angle 8. Now pause the video and try to come up with 2 more pair of vertical angles. All right, welcome back. Hopefully you said angle 1 and angle 4 and angle 2 and angle 3. Now, the relationship between vertical angles is that they're always congruent to each other. All right. Alternate interior angles. Alternate interior angles are angles that are inside the parallel lines and on opposite sides of the transversal. So let me explain what I mean by that. The interior is the area that is inside the parallel lines. First of all, so for an angle to be an alternate interior angle, it must fall inside the parallel lines. But in addition, it must be on opposite sides of the transversal. So for example, angle 5 and angle 4 would be an example of alternate interior angles. Likewise, grab a different color here, angle 6 and angle 3 would be alternate interior angles. So let's write this down. Angle 5 and angle 4, angle 6 and angle 3. Now, alternate interior angles are also congruent to each other. So if you know the measure of angle 5, you also know the measure of angle 4. If you know the measure of angle 6, you also know the measure of angle 3. All right. Now, alternate exterior angles, angles that are outside the parallel lines and on opposite sides of the transversal. So to be an alternate exterior angle, you must fall outside the parallel lines. Okay, that's what it means by exterior, on the outside of the parallel lines. And you have to be on opposite sides of the transversal. So for example, if I had angle 7, the alternate exterior angle with angle 7 would be angle 2. They're on opposite sides of the transversal. Or angle 8 and angle 1. So let's see, angle 7 and angle 2 angle 8, and angle 1. And they are also congruent. They are the same measure. So if you know the measure of angle 7, you also know the measure of angle 2. All right, let's look at the definitions a little bit more closely in example 1. In example 1, it says, in the diagram below, lines A and B are parallel and are crossed by transversal line T. Circle the correct relationship between each pair of angles. So, in part A, we're looking at angle 1 and angle 4. And we want to know, are they corresponding? In other words, are they matching corners? No, they're not matching corners, all right? Are they vertical angles? And the answer there would be yes, they are opposite. Remember, vertical angles are opposite angles formed by intersecting lines. So we're going to circle vertical angles. All right, part B, angle 2 and angle 6. So let me highlight that. Angle 2, whoops, let's use a different color. Angle 2 and angle 6, all right? Are they corresponding angles? In other words, are they in matching corners? And sure enough, they are. So we're going to circle corresponding angles, all right? All right, angle 2 and angle 7. Let me highlight those. Angle 2 and angle 7. Are they matching corners? No. Are they opposite angles? No. Are they alternate interior? No, because they're not inside the parallel lines. Are they alternate exterior? Yes, they were both on the outside and they were on opposite sides of the transversal. So they're alternate exterior angles. All right. In our last example, D, we want to look at the relationship between angle 3 and angle 6. Pause the video and try this one on your own. All right, welcome back. Did you choose alternate interior angles? If you did, you are correct. All right. Example 2. In the diagram below, lines M and N are parallel and they are cut by a transversal line P. Use the diagram below to mark the following statements as true or false. Correct any false statements. All right, let's start. Are angle 3 and 4, are they alternate exterior angles? Well, here's angle 3. That's inside the parallel lines. So I don't think they're going to be alternate exterior angles. Here's angle 4. Those are both inside the parallel lines. So I'm going to say this is false. And it said to correct it. So I'm going to say they're not alternate exterior. They are alternate interior angles. All right. All right, next statement. Angle 1 and angle 4 are corresponding. Corresponding means matching corners. So let's see if angle 1 and 4, angle 1 and 4, are they matching corners? Indeed they are. So that statement was true. So we don't need to correct anything. All right. All right. Angle 1 and angle 4 are congruent. Well, that's also true because corresponding angles are always congruent. All right. Angle 4 and angle 7 are congruent. So let's look at that. There's angle 4. Now, you may be tempted to check true on this, but I want you to notice that line O is not parallel to line M. And for corresponding angles, to be corresponding angles, you must have two parallel lines. So I'm going to say this is false because line O is not parallel to line in. All right, next statement. Angles 1, 3, 4, and 6 all measure 70 degrees. Well, let's look at angle 1 right here. Now, angle 1 and this angle form what's called a linear pair. And linear pairs add up to 180. So this angle would have to be 70 degrees. So we do know angle 1 is equal to 70. Now, angle 3 is directly across from it, so it is also equal to 70 degrees. All right. Now, angle 4 corresponds to angle 1, so that means it's also equal to 70 degrees. And then angle 6 is equal to 70 degrees, so that is true. All right, now let's erase some of this so I can see for the next question. All right, angle 4 and angle 6 are alternate interior angles. Angle 4 and angle 6 are alternate interior angles. Now, to be an interior angle, you have to lie inside or between the two parallel lines. So angle 6 does not lie inside the parallel lines. So I'm going to say that's false. Now I need to correct it. There is a relationship between angle 4 and 6. And I want you to notice that angle 4 and angle 6 are opposite each other. So those are called vertical angles. Angle 4 and 6 are vertical angles. All right. Example G. Angle 1, let me erase some of this. Hold on real quick. Angle 1 and angle 6 are alternate exterior angles. They're alternate exterior angles. Now, to be an exterior angle, you have to lie on the outside of the parallel lines. And they do both lie on the outside of the parallel lines. And they have to be on opposite sides of the transversal. Well, that's on the right side, and that's on the left side. So that is true. All right, now let's actually find some angle measures in example 3. So in example 3, it says line A is parallel to line B, and the measure of angle 5 is equal to 101 degrees. Find the measure of each angle below. Now, before we do this, I'm going to have you mark this up with the X's and O method. So I want to label all the acute angles. Label all the acute angles with an X. All the acute angles with the X. And all the obtuse angles that are larger than 180, label them with O's. Okay, so remember, every X is congruent to every X, every O is congruent to every O, and X plus O is going to equal 180. All right, so if I know the measure of angle 5 is 101 degrees, I can go ahead and write that right here, then I automatically know the measure of all the O's. I automatically know the measure of all of the O's. So I know angle 8 is also 101. I know the measure of angle 1 is 101. Whoops, why did I write 100? I meant to write 101 degree. And I know the measure of angle 4 is 101 degrees. Now, I also know that X plus O is equal to 180. So let me highlight this. I know that angle 5 plus angle 7, one of them's an X and one of them's an O, they equal 180. So what that means is, oh, I want a pen. Let's see. Let me write this down. The measure of angle 7 plus 101 is equal to 180. So the measure of angle 7 is equal to 180 minus 101. So that would be 79 degrees. So angle 7 is 79 degrees. Now, angle 7 is an x. Once you know one of the x's, you know all of the x's. So that means angle 6 is also 79 degrees. Angle 2 is 79 degrees. And angle 3 is equal to 79 degrees. All right, example 4. Line X is parallel to line Y, and the measure of angle 2 is 93 degrees. All right, now let's label this with our X's and O's. So let's label all of our acute angles with an X. All of our acute angles, X, 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 and X. All the obtuse angles, O, 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 O. All right, now the other thing we know is the measure of angle 2 is 93 degrees. All right, pause the video and try to get all the measures of the 8 angles below. All right, welcome back. All right, hopefully the first thing you did was wrote down that the measure of angle 2 is 93 degrees. And since it's an O, I'm going to label all the O's with 93 degrees. Angle 8 was 93 degrees, and angle 6 was 93 degrees. Now, to get all of the other angles, you're simply going to take 180 and subtract 93. So that would, no. So 87. And that concludes today's lesson, Parallel Lines Cut by a Transversal.